Welcome to Kubernetes Crashcasts, the podcast where we dive deep into Kubernetes concepts and make them easy to understand. I'm your host, Sheila, and today we're joined by our Kubernetes expert, Victor. In this episode, we'll be exploring DaemonSets, what they are, when to use them, and how they work. Victor, are you ready to demystify DaemonSets for our listeners?
Absolutely, Sheila. I'm excited to break down this important Kubernetes concept for our audience.
Great. Let's start with a quick overview of what we'll cover in today's episode. We'll begin with the basics of DaemonSets, their history and purpose, and then move on to how they differ from other Kubernetes controllers. We'll explore use cases, scheduling behavior, and even touch on some advanced topics like updating DaemonSets and security considerations. Finally, we'll wrap up with best practices and common pitfalls to avoid. But before we dive in, let's start with a fun quiz question for our listeners. Here it is. In a Kubernetes cluster with 5 worker nodes, if you create a daemon set without any node selectors or taints, how many pods will be created? Victor, any thoughts on this question without giving away the answer?
Oh, that's an interesting question, Sheila. It really gets to the heart of how DaemonSets work. I think our listeners will need to think carefully about the relationship between DaemonSets and nodes to figure this one out. It's a great way to test their understanding of DaemonSet behavior.
Indeed it is. We'll reveal the answer at the end of the episode. Now, let's start with the basics. Victor, can you tell us what DaemonSets are and why they were created?
Certainly, Sheila. DaemonSets are a type of Kubernetes controller that ensures that a copy of a pod runs on all or some nodes in a cluster. They were created to solve the problem of running background processes or services that need to be present on every node in a cluster. The history of DaemonSets goes back to the early days of Kubernetes. As cluster administrators started managing larger and more complex environments, they realized they needed a way to automatically deploy certain pods across all nodes. This was particularly important for tasks like log collection, monitoring, or networking plugins that needed to be present on every machine in the cluster.
That's interesting. So if I understand correctly, a daemon set is like a manager that makes sure a specific pod is running on every node in the cluster. Is that right?
That's a great analogy, Sheila. You're on the right track. To expand on that, think of a daemon set as a diligent manager who ensures that a specific task is being performed on every floor of a large office building. In this analogy, the office building is our Kubernetes cluster. Each floor represents a node, and the task is the pod that the daemon set manages.
Thanks for clarifying that, Victor. Now, how do daemon sets differ from other Kubernetes controllers like replica sets or deployments?
Great question. The main difference lies in how they schedule and manage pods. Replica sets and deployments are designed to maintain a specified number of pod replicas across the cluster, regardless of which nodes they run on. They're focused on maintaining a desired state for your application. Daemon sets, on the other hand, are node-centric. They ensure that a single copy of a pod runs on every node or a subset of nodes in the cluster. This makes them ideal for cluster-wide operations or services that need to be present on every node.
I see. So, if I wanted to run a logging agent on every node in my cluster, a daemon set would be the way to go, right? Can you give us some more examples of when we might use daemon sets?
Absolutely. You're spot on with the logging agent example. Here are some common use cases for daemon sets. 1. Logging agents. As you mentioned, to collect logs from every node. 2. Monitoring agents, to gather metrics from each node. 3. Network plugins, to set up networking on each node in the cluster. 4. Storage plugins, to provision storage resources on each node. 5. Security agents, to run security scans or enforce policies on each node. These are all cases where you need a specific process running on every node in your cluster to provide infrastructure-level services.
That's really helpful, Victor. Now, I'm curious about how daemon sets handle scheduling. Do they interact with the Kubernetes scheduler differently than other controllers?
You've touched on an important point, Sheila. Daemon sets do indeed have a unique relationship with the Kubernetes scheduler. By default, DaemonSets will create a pod on every node in the cluster, bypassing the normal Kubernetes scheduling rules. This means that even if a node is marked as unschedulable, the DaemonSet will still place a pod on that node. However, DaemonSets also respect node affinity and taints tolerations. This allows you to control which nodes the DaemonSet pods run on. For example, you could use node selectors to run a DaemonSet only on nodes with specific labels, or use taints and tolerations to prevent DaemonSet pods from running on certain nodes.
That's fascinating. It sounds like DaemonSets give you a lot of control over where pods run. But what happens when you need to update a DaemonSet? Is it similar to updating a deployment?
Great question, Sheila. Updating a DaemonSet is similar in some ways to updating a deployment, but there are some key differences. Like deployments, DaemonSets support rolling updates. When you update a DaemonSet, it will gradually replace the old pods with new ones. However, the way this happens is a bit different. In a DaemonSet update, 1. The old pod is deleted on a node. 2. A new pod is immediately created on that same node. 3. This process repeats for each node in the cluster. This ensures that every node always has one and only one instance of the DaemonSet pod running, even during updates. DaemonSets also support rollback, allowing you to revert to a previous version if an update causes issues. However, it's important to note that DaemonSet updates can be more impactful than deployment updates, as they affect every node in your cluster simultaneously.
That's really important to understand. It sounds like updates to DaemonSets need to be handled carefully. Are there any security considerations we should be aware of when using DaemonSets?
Absolutely, Sheila. Security is a crucial aspect to consider when working with DaemonSets. Since DaemonSet pods run on every node and often require elevated privileges, they can pose significant security risks if not managed properly. Here are a few key security considerations. 1. Principle of least privilege. Only give DaemonSet pods the minimum permissions they need to function. Avoid using the host network or running pods as root unless absolutely necessary. 2. Image security. Use trusted and regularly updated images for your DaemonSet pods. Implement image scanning to detect vulnerabilities. 3. Network policies. Use Kubernetes network policies to control the traffic to and from your DaemonSet pods. 4. Pod security policies. Implement pod security policies to enforce security best practices for your DaemonSet pods. 5. Regular audits. Regularly review and audit your DaemonSets to ensure they're still necessary and configured correctly. Remember, because DaemonSets run on every node, a compromise in a DaemonSet pod could potentially affect your entire cluster.
Those are really important points, Victor. It's clear that while DaemonSets are powerful, they need to be used responsibly. Can you share some best practices for using DaemonSets effectively?
Certainly, Sheila. Here are some best practices for working with DaemonSets. 1. Use them sparingly. Only use DaemonSets for processes that truly need to run on every node. Overuse can lead to resource contention. 2. Resource limits. Always set resource requests and limits for your DaemonSet pods to prevent them from consuming too many resources on the nodes. 3. Node selectors and tolerations. Use these features to fine-tune which nodes your DaemonSets run on. This is especially useful in heterogeneous clusters. 4. Update strategy. Configure an appropriate update strategy. The default is rolling update, which is usually a good choice, but you might want to adjust parameters like max unavailable. 5. Health checks. Implement proper liveness and readiness probes to ensure your DaemonSet pods are functioning correctly. 6. Monitoring. Set up monitoring and alerts for your DaemonSets to quickly catch any issues. 7. Version control. Manage your DaemonSet configurations in version control, just like any other part of your infrastructure. By following these practices, you can ensure that your DaemonSets are reliable, efficient, and secure.
Thank you, Victor. Those are excellent tips. Now, before we wrap up, can you share a real-world implementation of DaemonSets that you've encountered?
Certainly. One common real-world implementation I've seen is using DaemonSets to deploy a logging solution like FluentD or FileBeat. In this scenario, A daemon set is used to ensure that a logging agent is running on every node in the cluster. This agent collects logs from all the containers running on that node and forwards them to a centralized logging system like Elasticsearch. The daemon set ensures that as new nodes are added to the cluster, they automatically get the logging agent deployed. And if a node goes down and comes back up, the logging agent is automatically restarted. This implementation allows for comprehensive log collection across the entire cluster, which is crucial for monitoring, troubleshooting, and compliance in many organizations.
That's a great example, Victor. It really illustrates how daemon sets can be used to solve real-world problems in Kubernetes clusters. Now, let's reveal the answer to our quiz question from earlier. Remember we asked, in a Kubernetes cluster with 5 worker nodes, if you create a daemon set without any node selectors or taints, how many pods will be created? The answer is 5. A daemon set without any node selectors or taints will create exactly 1 pod on each worker node in the cluster. To summarize what we've learned today, 1. Daemon sets ensure a pod runs on all or some nodes in a Kubernetes cluster. 2. They're ideal for cluster-wide operations like logging, monitoring, and networking. 3. Daemon sets have unique scheduling behavior, bypassing normal scheduler rules. 4. Updating daemon sets requires careful consideration due to their cluster-wide impact. 5. Security is crucial when working with daemon sets due to their privileged nature. 6. Best practices include using them sparingly, setting resource limits, and implementing proper monitoring. Victor, is there anything else you think we should have covered if we had more time?
Great summary, Sheila. If we had more time, we could have delved deeper into advanced topics like using daemon sets with stateful applications, integrating daemon sets with custom resource definitions, CRDs, or exploring how daemon sets interact with cluster autoscaling. These are all fascinating areas that show the full power and flexibility of daemon sets in complex Kubernetes environments.
Those do sound like interesting topics, Victor. Maybe we'll cover them in a future episode. To our listeners, thank you for tuning in to Kubernetes Crashcasts. If you found this episode helpful, please subscribe to our podcast and leave us a rating. Your support helps us continue to create content that demystifies Kubernetes concepts. Remember, whether you're running a small cluster or managing a large-scale Kubernetes deployment, understanding concepts like daemon sets can make a big difference in how effectively you use Kubernetes. Until next time, keep learning and happy clustering.